Guys, Sarah here from Crystal Cove Conservancy again, and I just wanted to give you guys a demonstration how you can check for significance with your graphs by adding error bars to your bar graphs. So to do this, you're going to want to start out with the averages that you guys calculated already for your data. So this is some example data from 2017. Here are the two averages I've calculated for my two treatments here. And what we're going to do is perform a series of calculations so that we can find our confidence interval for both of these sets of data. And then we'll use that to create a graph with error bars on it, which will let us see whether or not we have significant findings in this data set. So you should have the instructions. You might want to follow along. I think that that'll make it easier to understand everything. But the first thing I'm going to want to do is add in the rest of my tables so that I have everything ready to go. So the different numbers we'll need to calculate our confidence interval. We'll need to figure out our alpha. We'll also need to figure out the standard deviation for each of our treatments. It's like the variation within our data. We'll need to figure out our population size, or the number of data points that we have. And then finally, we'll need to figure out our confidence interval, or confidence. So now that I have these columns set up, I can go back and start filling them in. So the alpha is kind of like how confident you want to be. So usually for ecological studies, we want a 95% confidence interval. Some medical studies might be 99%, but we really just need 95%. So that means our alpha is 0.05. It's 1 minus 0.95, which is our confidence. So 0.05. So you can, 0.05. You can just enter that in. To calculate the standard deviation, you're going to use the formula STDEV, and then do an open parentheses, and then you'll want to highlight all of the numbers in that data set. So there's for adult shrub, and then I'm going to do the same thing for the no adult shrub data points. And so that gives us our standard deviation, and this is a statistical number that we use. It basically tells us how much variation there is in our data set, or how different the numbers within our data set are from each other. If there's a low standard deviation, it means the numbers are clustered very tightly together. If there's a large, like a high standard deviation, it means the numbers are spread far apart. Next up, we want to find our population size. So this is really easy. You really just need to count the data points in your treatments. So 1, 2, 3, 4, 5, 6, 7. So I have 7 for no nurse, or 7 for adult shrub, and 7 for no adult shrub. And now I can use these 3 numbers to calculate my confidence interval. So the confidence interval again shows the range that 95% of the means would be between, based on the means that we found. So the formula to do this is equal sign, of course, and then confidence. And then what you're going to need to do is type your parentheses, and then you'll want the alpha, the standard deviation, and the population size. So I typed in confidence, open parentheses. I'm going to click on the alpha square, comma, standard deviation square, type another comma, and then the population size. And then I'm going to close the parentheses. And that would be my confidence interval for the adult shrub treatment. And I'm going to do the same thing for the other one. So you actually need to do this for both treatments. So again, alpha, comma, standard deviation, comma, population size. And Google Sheets does the work for us and calculates our confidence interval. And so then what I'm going to want to do next is insert a graph. And this is going to start out sort of the same way that you guys did before. So you go into Insert, Add Chart, just like before. Oh, there it is. You can see that just like before, it's kind of gotten weird with my numbers over here. So I'm going to go and make sure that vertical axis minimum values start to 0. Maximum axis is fine. Actually, I might make that 25 just because I want to see my confidence intervals. I've, of course, made sure that this is a column chart and not a pie chart or something else, because that's what I need. And then finally, this is where stuff is going to start to get a little bit different. So the first thing I'm going to want to do is under data, see where it says switch rows columns. I'm I'm going to click on this. And so that's going to make these both independent. So this is kind of cool from a picture perspective because now my bars are two different colors. But this is also going to allow me to add 2 different confidence intervals, one for each of my 2 treatments. Come back. Okay, so next step is I'm going to go to Customize. And I'm going to go to Series. And I'm going to click where it says Add Error Bars. So I'm going to highlight that. But that's not all. To make sure my error bars are correct, I'm going to have to do a couple things. So the first thing I'm going to want to do, click on this bar. I have an error bar. I'm going to change the percent from percent to constant. So that means instead of using a percentage, I'm going to enter a number. And then I want to set the value to that confidence interval value that I have up here. So 3.017. So that's changed the length of my bar. I'm going to do the same thing for this one. So I click on the other column, error bar. I want to change that so it says constant. And then I'm going to enter what it says here, 1.82. Do 1.821. And so that again has changed the length of my error bars. And so what you can do now is you can look at this graph, and to figure out if something's statistically significant, you're going to want to see if these different error bars overlap. So if the error bars don't overlap at all, like if you see these are totally different, like this one's down here and this one starts up here, that means that you can say that your data with a 95% confidence interval is likely to be highly significant. So it's very likely that these 2 data sets are different and that the difference that you see here is actually meaningful. If the error bars overlap less than 25%, which this one looks pretty close. I would say it's about 25%, maybe a little bit less. Then you can say that your findings are likely to be significant with a 95% confidence interval. If these bars were to overlap a lot, so let's say, let me change this, and I'm just making up a number. Let's say it's 5. So you can see how much these bars overlap a lot. You can say it's not likely that the differences are significant. So we can't really tell if the differences that we see here are because of random variation or because there's actually a difference in these 2 populations. So depending on what you guys find, it may be really difficult for you to tell if these error bars overlap or not. If you're having a hard time telling, if it just seems difficult for you to see yourselves, please let us know. We would be more than happy to run some other statistical tests and give you a better answer. And if you find that your results aren't statistically significant, that might just be because of our sample size. I know especially with our seedlings this year, we've noticed a couple of them are dying, so we'll probably have to take them out of our sample, which means we have a very small sample size, so it's harder to get statistically significant results. If you guys are interested, you can also let us know and we can give you the full data set with all 70 plots included. And if you have more plots, it's more likely that you could get statistically significant results. So it might be a little bit easier to find something that is significant. So that's a quick introduction to how to add error bars and then use those to check for statistical significance. If you guys do have questions, please feel free to reach out and contact us. And as always, we're really, really interested to see what you find.